Welcome to Machine Learning course. In this course, we'll start with the theory of ML that help you grasp the basic concepts and then move towards the practical knowledge, where I'll tell you about the algorithms with its real-world examples. So, first of all, what is ML? Arthur Samuel, a pioneer in the field of artificial intelligence and computer gaming, coined the term machine learning, and he defined machine learning as a field of study that gives computers the capability to learn without being explicitly programmed. In a very layman term, machine learning, or ML in short, can be explained as automating and improving the learning process of computers based on their experiences without being actually programmed, that is, without any human assistance. The process starts with feeding good quality data and then training our machines or computers by building machine learning models using the data and different algorithms. The choice of algorithms depends on what type of data do we have and what kind of task we are trying to automate. So let me give you a really small example. Let's take an example of training of students during exam. So while preparing for the exams, students don't actually cram the subjects but try to learn it with complete understanding. Before the examination, they feed their machine, that is brain, with a good amount of high quality data, that is questions and answers from different books or teachers' notes or online video lectures. Actually, they are training their brain with input as well as output. That is, what kind of approach or logic do they have to solve different kind of questions. So each time they solve practice test papers and find the performance, that is accuracy, by comparing answers with answer key given. Gradually the performance keeps on increasing and they gain more confidence with the adopted approach. That's how actually models are built and trained with data. Both inputs and outputs are given to the model, and when the time comes to test on the data with input only, we achieve our model score by comparing its answers with the actual output which has not been fed to the machine. So that was a really small example. What exactly is the basic difference between ML and a traditional programming? So as you can see on the image, in traditional programming, we input the data and a program logic and run it through the machine and get the output. But in machine learning, we feed the data, that is the input, and the output, that is both of them, right? We feed input and output, run it on a machine during the training, and then the machine creates its own programming logic which can be evaluated while testing. So what does exactly learning means for a computer? A computer is said to be learning from experience with respect to some class of task. Its performance in a given task improves with the experience. So that is the official definition, or you can say that is the formal definition of machine learning. So a computer is said to learn from experience with respect to some class of task T and performance P if its performance at the task is measured by P and it improves with experience E. So for example, if a computer is playing checkers or chess, right? So E here becomes the experience of playing many games on the checkers. T is the task of playing games. P is the probability that the program will win the next time. How do things work in reality? So if you're talking about the online shopping, there are millions of users with unlimited range of interest with respect to brands, colors, price range and more. While online shopping, buyers tend to search for a number of products, and when they're searching for a product, when they're searching for a product frequently, it will make the buyer's Facebook, web page, search engine or that online store start recommending these different offers. So in this way, they try to target the customers with best prices, best deal, a sale, a discount coupons, etc. So that is one of the that is one of the implementation of machine learning. Apart from that, even in healthcare also, machine learning is doing a great job. Researchers and scientists have prepared models to train machines for detecting cancer. You also might have used Google Photos or Apple Photos, where the machine learning recognizes faces and they can recognize a different person. Google Lens, where the ML image text recognition model can extract from the images you feed in. Gmail, which categorizes email as social, promotions, updates, or forum, or even spam, and many virtual assistants, Siri in iPhones and Google Assistant in Android phones. So they are virtual assistants which can convert speech into text. If you ask your assistant a question or give it some task to do, they'll first convert it into the text that you can see on the screen, and then the task is performed. So in this category, these are all part of ML. So this was a general introduction of machine learning. Now we'll see data pre-processing. First of all, why do you need data pre-processing? I'll tell you what exactly it is, but I'm sure you'll understand with this example. So why do you need data pre-processing? So let's imagine that you are going on a trip. It could be out of country, it could be out of your city. So you're going on a trip, you want everything to be prepared, right? You want your toiletries to be good, you want your clothes to be exact, and you want your ticket details. If you're going via train, you want to be confirmed that you have the ticket, or if you're going out of country, you have to be sure that you have the passport, the visa, and all that. So these are all the preparation before you go on a trip, right? Before you take a long trip. And why the preparation is necessary? Because if you forget something in the future, then you'll be in a big problem, right? So we prepare ourselves before leaving the house. So in the same sense, the data needs to be prepared before giving it to the machine, right? So that is why we need data processing, and that is what data processing is, data pre-processing is. So in the data set, what generally you will see are the two variables. One is independent variable, one is dependent variable. So the basic difference between the two variables is that we predict dependent variables with the help of independent variables. So in this example, as you can see, there are four different columns: country, age, salary, and purchased column. So based on a person's age and his salary, we can predict that if he will buy a car or not, right? So this is an actual data set. This is not a predicted data. So based on previous data set, we can see that the person having age 44 and salary 72,000 did not purchase the car. But a person having the age 27 and salary 48,000 did purchase the car. Maybe the car was a sports car, that is why he purchased, right? So based on these two different columns, we predicted that either a person will purchase the car or not. So these two columns, age and salary, will become the independent variables, and purchase column will become the dependent variable. So these are four different which we do in data pre-processing. One is impute missing data, that is we fill in the missing values. We encode the categorical data, that is we change the categories into numbers because machine can't understand categories. Split the data set, we split the data set into training and testing data set, and we use the training data set to train the machine, and we use the test data set to check its accuracy. And the last is feature scaling. Feature scaling means that we want to scale all the features in one dimension or in one variance under one scale so that they can be easily compared. Now we'll start with missing data. How to fill in the missing data. So one option is, if you have certain row with missing data, you can either delete the whole row which have the missing data. That could create a problem in certain situations where values are of utmost importance. The other option is to take the mean, median, or mode of the columns. That is the easy way. We all know that the columns are in numbers, so they can be, the mean, median, and mode can be easily taken. For example, if we conducted a survey and the person forgot to mention the age in cells, so we can look at the and fill in the missing values with the help of mean, median, or mode. That's the simplest missing data technique we can use. So because we are filling the values with mean, median, or mode, so we will import the library called a simple imputer is a function. sklearn is a library where all the most of the machine learning methods reside. So sklearn.impute, and from this library we will call simple imputer. And one thing to note is that mean should be used when you know that there are no outliers. Otherwise, we should always use median. Let's see some code and I'll tell you how to fill in the missing values with the help of mean, median or mode and with the help of library. So here is the code of imputing the missing data, of how to impute the missing data in the columns. So before that, let me show you the data which we are all working on. So this is a CSV data. We have 4 columns: country, age, salary and purchased. And as you can see that some of the rows have missing values. For example, this line has salary missing and this line is missing the age value. So we will be imputing these missing values with the help of the libraries. So first of all, these are the common libraries: the NumPy, the Pandas and the Matplotlib. Matplotlib is a famous library for diagram. In this particular scenario, we are not using the Matplotlib, but in the later section of the course, when we will talk about algorithms, then I'll show you what exactly is the use of Matplotlib. So first of all, let's import the dataset. And the name of the dataset that we are importing is data.csv and storing it in a dataset variable. So to import the dataset, move the cursor at the end of the line and press F9, or either select the whole line and press F9, or you can press this button. Now the dataset has been imported. As you can see, this is the dataset. It has country, age, salary and the purchased column. Now the next is the independent variable. So as you all know that country, age and salary are the independent variables and purchased is a dependent column. So with the help of iloc, dataset is the name of the variable, right? And with the help of iloc method, we'll store all of the rows and all of the columns except for last, there is -1. So except for the purchase column, we'll store every column in the independent variable. And this is the independent variable which has country, age and salary in it. Now for the dependent variable, and in this line we'll store only the last column, that is the fourth column, right? So executing it, and this is the data set. Oops, sorry. And this is the dependent variable, the yes no column. To use the imputer method, first of all you have to call the simple imputer method from the sklearn library. So from sklearn.impute, we have to import the simple imputer. That is the name of the method. And then we'll create an object to use the impute function. So using the method simple imputer, giving 2 parameters. So what are the 2 parameters? You have to press Ctrl and I, and it will open up the help section or help document where you can see the simple imputer method and its parameters. So the first parameter we have to deal with is missing values. So because there are missing values in our data set, so np.na and np.nan helps the method actually to tell that we are missing or filling the missing values, right? And the strategy we are using is mean. So by default it is mean. Other than that, you can use median or mode, that is most frequent or constant, right? So these are the 2 parameters you need to take care. So using this method, storing it in a variable imputer, okay, and then running the first line, that is imputer. Now the imputer has been called, as you can see. Now we have to fit the imputer method, right? Because remember there are 2 columns that have missing values, that is age and salary. So we are giving 1 colon 3, that is starting from 1. Remember Python starts from 0. So the first column and 2 means the second column. 0, 1, 1 means the second column and 2 means the third column, and 3 is the last column which will not be included. So we'll fit this method, imputer method, using the fit method, imputer.fit, and this is the name of the data set. The independent variable is the data set which I have first three columns stored. So we'll give only the second and the third column, and then we'll transform the columns. The first method is to always fit the values, and then using this variable again we'll transform the columns and store it again in the independent variable. Once I run both of these lines, now the independent column will have the mean variable. So this is the mean value of all the values file and in this, right? So that is how you impute the missing values. And if you notice, we have used mean in this situation, right? I could have used median or mode in this case, but why I just chose to use only mean, right? Because in this situation, median or mode won't make much sense, because we are dealing with age and salary here, right? Um, so if we have took a survey and if one or two person forgot to mention their age in the columns, so at that point of time, the mean age would make more sense than mode. Mode is because mode, as you all know, is the most frequent number, right? In that case, mode won't make much sense, and median, because median takes the middle value. Remember that I told you that mean should be used when you know that there are no outliers in the data set. But when there are outliers in the data set, you should always use median. So it depends on the data set, right? And because I can see in my data set that there are no outliers in the age column, that's why I used mean. If there would have been an outlier, for example, 2 or 3%, if they might have written their age as 90 or 100, they're outliers. So in that case, I would use median. And same goes with the salary column also. So in that case also we took mean, because that makes more sense in this scenario. But otherwise, you have to see the data set and you have to come to a conclusion that which method should you use. Now I'll show you how to encode the variables, the category, to a number. Now the next process is encoding. So why do you need encoding? First of all, encoding means to convert categories into numbers for the ML algos and models, because machine cannot understand categories, right? They can only understand numbers. So initially, categories are divided into two categories. One is nominal, other is ordinal. Nominal means that they have no particular order. For example, a pen, pencil, and an eraser, they have no particular order. Three animals, cow, dog, and cat, they have no particular thing in order. But on the other hand, ordinal means that they have some kind of order. For example, excellent, good, bad, and fantastic, okay, don't like. So this is an order. You are decreasing the order from very good to very bad. So this is ordinal. So now we need to convert these categories into numbers. The main problem is that the machine cannot understand categories. So that is why we're doing it. We use the label encoding library and one hot encoder method. So these are two different methods. I'm sorry, these are not libraries. These are two different methods, and it is also available from the sklearn library. So now let's see how to convert categories into numbers with an example. So this is in continuation with imputing the missing values, because that is the first step you need to do. You impute the missing values and then you need to encode the data. So for encoding the data, there are two common methods that is used. One is called label encoder, the other is called one hot encoder. And these both methods from sklearn library, that is sklearn.preprocessing. So from the sklearn.preprocessing, we have to import these two methods. So now as you can see in the data set that we have only one column, or rather two columns. First of all, we deal with the independent columns. So in independent columns, we have only one column that is categorized, that is country column, which has France, Spain and Germany in the values. So we'll have to convert it into numbers. So to convert into numbers, you have to call the label encoder method, storing it in a variable. You can give any name to the variable. So using the variable will fit transform the first column. So this is the method, that is dot fit underscore transform, and then using the first column we'll convert into numbers. So now running it, and I'll show you the difference. So as you can see that the numbers has been converted, that is 0, 1 and 2. So 0 here means France, 2 means Spain and 1 means Germany. Now remember that 0, 1, 2 doesn't mean that France is lower or Spain is the highest country or Spain has the highest value among the three. That is not the case. This can be quite confusing sometimes. Sometimes when there are two values, for example male and female, and if male comes 1 and female does 0, so it doesn't mean that the male is higher than female. It's just a representation. The categories can be converted to numbers. So in order to avoid that situation, we can use one hot encoder method. So before explaining one hot encoder, let me show you what the output looks like so that you can easily understand the concept. So after one hot encoder, the column, the dataset column that has three values, France, Spain and Germany, will be converted into three different columns and one for each column. So this is for France column, this is Spain and this is for Germany, or this could be Spain or this could be Germany, but you get the idea. So because we have three different values in the state in the country column, so one hot encoder divides it into three different columns, and wherever the France is there it will assign it 1. In the second column, wherever the Spain is there, it will assign it 1. I guess this is Germany column because Germany is in third position and this is in third position, so this is the Germany column and this is the Spain column, right? Now let me explain you how one hot encoder works, or how to use one hot encoder. So what it does is it gives every column, every value the number 1, but in its unique column. For example, it will give, because the country column is a single column, it will divide the country column into three different columns. One column will be for France, that means wherever France is there, it will give the France 1 and rest of the value 0. The second column will be of Spain or Germany, and it will give the value 1 wherever Spain is there or Germany is there, depending on which of the column will it create. And the third will be of the last value. So that is what one hot encoder does. And to use one hot encoder, we use the method column transformer, because that is the method which uses one hot encoder method. So to use column transformer, we'll import it from the library sklearn.compose, and we'll import column transformer and use the column transformer and using the one hot encoder, both of them. So this is the method of one hot encoder, and this is the column number which we're going to transfer or transform. So storing it in a variable called CT, and then using this CT to fit transform the independent value, because this is the independent value, that is 0. And so you also use the array method to transform the columns into transform the column which is numbers into the categories. So once it is executed, you can see that there are three different variables, or rather I would show you here. As you can see that there are three different columns for the country. So in the same way, you can also transform the last dependent variable, which is a yes no, into a numbers, that is 0 and 1. So for that, one hot encoder is too much, so we'll use the label encoder. After running it, you can see that the dependent variable has been converted to numbers. So in this way, this is the second step where you can transform your categories into numbers. So once you have filled in the missing values and you have converted the categories into numbers, now the time is to split the data. So we split the data set into training and test set. Training set is used to train the model. Test set is used to test the performance or accuracy of the ML model. You should always remember the one golden rule though. Never mix training and test dataset. What do I mean by it is you should always split the dataset because you have to train the model. That is the general golden rule we have. So you have to train the dataset and then you should test the accuracy of the model. So now let's move on to code and see how you split the dataset. So this is the third step where we'll split the dataset into training and test set, and it comes after the first two steps are performed. So after imputing the missing values and after converting it to our numbers, now we'll split the dataset. And why do we split the dataset? You know that. So to split the dataset into training and test dataset, we'll use the method train test split from the library sklearn.model_selection, and then we'll define four variables, two for independent values and two for dependent values. There will be independent training set, independent test set, and dependent training set and dependent test set. And then we'll use the train test split method and pass in two different variables, that is independent and dependent set. And it uses two more parameters. One is size, how much you want to divide the test size and the training data set. So in this case, I'm taking 20% as test set and remaining 80% as the training data set. So it means that we will train the data set or the machine using 80% of the data set, and will test the machine, its accuracy, using the 20% of the test data set. So here I have taken the test size as 20%. You can take the test size as 15%, 25% or 30%. So 15 to 30% is the industry standard what the test size should be. And this random state 0 means that it has been randomly divided. So whatever value, the 20% value it will take from the original data set will be all random. बंद कर दो. So here I have taken the test size as 20%. You can take the test size as 15%, 25% or 30%. And 15 to 30% is the normal, and 15 to 30% is the industry standard that they take. Maximum. So 15 to 30% is the industry standard what the test size should be. So a small example would be here would be the student. So a small example here would be a student preparing for its. So a small example here would be a student preparing for his exam. So a small example here would be a student preparing for his exams. Prepare for their exams. So a small example. So a small example here would be students preparing for their exams. So a small example here would be the students preparing for their exams. So a small example here would be A small example here would be the students preparing for their exams. So a small example here would be the students preparing for their exams. They train themselves with the help of the training manual, the online books, notes and all that. And after they train themselves, that means after they train their brain, they test themselves whether whatever they have learned is correct or not, is accurate or not, right? So they test themselves, and test cases are usually smaller than the training cases. So just take the example of a normal examination in a semester that is 6 months long. So what you read in those and what you learn in those 6 months in this semester, but everything is not asked in the test set, right? When your exams are there, everything is not asked. So usually 20 or 30% is asked. So that is what is same with machines also. We have to divide the data set into training and test set so that we can train the machine using the training set and test the machine using the test set. So once I run it, and as you can see in the variable explorer that there are 4 new variables now. One is independent training set. So as our data set is already very small, so it has 10 values. So 80% means 8 values has been assigned to the training set. So these are the 8 values, and these are that was the training set. So these 2 values are for the test set. These both are independent variable. The dependent test has also this is the dependent column training set that it has 8 values, and it is the dependent column test data set that has 2 values. So in this case you'll divide the data set into training and test set, and when we use the algorithm, machine learning algorithm will use these training set and test set to train the machine and test the machine. So I'll show you how once we start learning about the algorithms. So now we'll see what is feature scaling. It is applied to independent variables or features of data. It basically helps to normalize the data within a particular range. Sometimes it also helps in speeding up the calculations in an algorithm. A real-world dataset contains features that highly vary in magnitudes, units, or range. Normalization should be performed when the scale of a feature is irrelevant or misleading. Algorithms which uses equivalent distance measure are sensitive to magnitudes. Here feature scaling helps to weigh all the features equally. Formally, if a feature in the dataset is big in scale compared to others, then in an algorithm where equivalent distance is measured, this big scaled feature becomes dominating and needs to be normalized. The most common technique of feature scaling are normalization and standardization. Normalization is used when we want to bound our values between two numbers, typically between 0, 1 or minus 1, 1, while standardization transforms the data to have 0 mean and a variance of 1. They make our data unitless. The difference is that in scaling, you're changing the range of your data, while in normalization, you're changing the shape of the distribution of your data. Use that. The last is feature scaling. So feature scaling is usually the last step after the first 3 steps are done. We'll again import the method. The library is sklearn.preprocessing, and from it we'll import the standard scalar method. And then using the standard scalar method, storing it in a variable. It's a good practice to store it in a variable and use the variable again and again, because first, that is short to write, it saves time. So using the variable sc.indep, that is this method, this variable, which is storing standard scalar method. So sc underscore indep fit transform, and this is the first independent training set because we need all the variables to be on the same scale. So this is the independent columns, and then this is the independent test column. So first was the train column, and then we have the test column. So once you run it, we can see that the independent train and test has been converted. So this is the training value and this is the testing value. I know it's not easy to read, but this is the scaled version of those values which a computer can understand and which is used to give the data to the machine. So that's it. For the 4 steps of data pre-processing. Before you give it to the machine, you have to prepare the data. So these were the 4 steps, and I hope you like the video, and I'll see you on the next topic, which we are going to start as machine learning, and we'll tell you the different algorithms. I'll see you on the next video. Thank you.